Hey students, in this particular session we'll discuss about derived quantities and derived units. We know already about the fundamental quantities, right? So those are the quantities of which the units cannot be represented in terms of other units, or they are independent of the units of other physical quantities. But if you talk about the derived quantities, these are those quantities of which units can be represented in terms of the different values of the units of fundamental quantities and raised to the power proper value, right? So we can write quantities units of which can be represented in terms of units of one or more fundamental quantities with raised to proper values, right? Raised to means you can write as cube in terms of minus half, plus half, 3 by 2, etc. So for example, we know in mechanics there are three fundamental quantities, right? One is mass, one is length, and another one is time. So these are the fundamental quantities, right? And the corresponding units of these fundamental quantities, as we know, are called fundamental units, right? So if you talk about the SI units, only SI units, we know the mass has got unit called kg or kilogram, length unit is meter, and times unit is second. Now we'll see how different derived quantities can be written, or as their units can be written in terms of the units of these fundamental quantities. For example, if you take the derived quantity like area, surface area. What is area? Area can be written as length times length, or you can talk about breadth or height, but all these things denote the fundamental quantity length only, right? So this is the fundamental quantity representation of this particular derived quantity, and its unit will be what? Units will be meter into meter, that is meter square. So see, the unit of this particular derived quantity can be represented in terms of the unit of a fundamental quantity or fundamental unit and raised to its proper power, right? Similarly, for volume, I can write this as length into length into length, or you can call it as length, breadth, height, but all denote the dimension of length only, right? So this will be meter into meter into meter, it will be meter cube, right? Now let's talk about, as we know, velocity. Now velocity has got dimension of length divided by time. So see, in this case, this particular derived quantity can be represented in terms of two different fundamental quantity, right? Now what about the unit? Unit will be meter, and time has got unit second, so its unit will be meter per second, or meter second to the power minus 1. Now if you talk about similarly acceleration will be what? Length per unit time, this is velocity, again per unit time, that is rate of change of velocity. Now it will have unit of meter divided by second into second, or that is meter per second square. Alright. Now if you talk about the unit called force, derived quantity called force. Force is what? Force is mass into acceleration, and we have already represented acceleration in terms of the other fundamental quantities. Mass is another fundamental quantities, so I can write it as mass into length into divided by time into time. So it will have the unit of mass is kg meter per second square, and this particular unit is also known as Newton and is represented by capital N. Now if we talk about pressure, pressure is what? Pressure is force per unit area, right? Now just try to see, we have already derived the SI unit, we have already derived the unit of force in terms of the unit of fundamental quantity. We have already derived the unit of area in terms of the fundamental quantity. So the pressure will have the unit, right, kg meter per second square divided by meter square. So its unit will be kg meter to the power minus 1 second to the power minus 2, and this particular thing is also known as Pascal, that is kg meter to the power minus 1 second to the power minus 2. So if you talk about again work done will be what? Force into displacement or distance, right? So you know the unit of force, that is Newton, that is kg meter per second square, and it will be just meter because distance has got this unit of meter, and this particular thing is also called joule, right? Now if you find power, power is nothing but work done per unit time. Time is again a fundamental quantity, right? So I can write it as Newton meter second inverse, and this is called nothing but watt, represented by capital W. So just try to appreciate that we have derived all the quantities and their units in terms of just the unit of this fundamental quantity. So that is the essence of derived unit, and there are a lot other more quantities, the units of which can be derived just in terms of the unit of fundamental quantities, whether these three quantities or the quantities that denote that are useful in electrodynamics, optics, thermodynamics, like temperature, like electric current, like luminous intensity, etc., right? So student, this is all about derived quantities and derived units.